Mr. Chairman and members of the Commission, Secretary Vonk, while they start the slides up there, I just wanted to share with you that at the beginning of last week we had information that we've had a positive identification of Quagga Mussels in Angustora Reservoir. We had the initial notice at the beginning of last week. The end of last week we had confirmation of that. This is the first confirmation of a zebra or a Quagga mussel in South Dakota, and right now this is simply an initial briefing we wanted to give you on it. Our plans are to get together a work group and move forward from here with our partners, but we wanted to have Mike Smith give you a brief update and overview of these types of invasive species mussels, and have that so you have some background when we bring you an update as we learn more and we develop a plan to work on this issue. Mike?
Thank you, John, members of the Commission. Basically what I'm going to try to do here pretty quick is give you Zebra Quagga Mussel 101 so you can really answer questions, because this is typically an issue where a lot of the public's going to want some information. So when we talk about zebra and quagga mussels, they're actually part of the Dreisseniid mussels. There's two species, and they're really closely related. A lot of people refer to them as cousins. Zebra mussel usually gets the most press. That's the one on the left there. And then quagga mussel is on the right. Physically, they're really similar to each other. Zebra mussels tend to have more of a D-shaped, and that's actually one of the easiest ways to differentiate between the two when you have a shell. If you put a zebra mussel on that flat edge, it'll stand up. A quagga mussel has maybe I can't do it. It has the rounded edge on the bottom, and it won't be able to stand up if you put it on a table. Color very similar. Typically, zebra mussels have that striping, which is why they're called zebra mussels, but they don't have to have that. Quagga mussels tend to lack striping. Size-wise, they're both very similar. They're going to be less than an inch in size. The major characteristic that causes huge problems with zebra and quagga mussels are these byssal threads. What these do is allow them to attach to hard surfaces. That's when you see those pictures of entire boat hulls being covered, boat motors, a shopping cart that is in the river or something like that would be covered with zebra mussels. Quagga mussels also have those, but they also kind of have another issue come up with. They actually can attach to soft surfaces as well, so mud, some of the shales and stuff like that we have in our state. No native mussel species have this structure, and that's why they're able to outcompete our native mussels so easily. Reproduction-wise, adult mussels release their gametes into the water, so the males release sperm, females release eggs. When those are released and fertilized, we actually call that a veliger, and that's what you're going to hear a lot of throughout this process is veligers, and what that really is the larval stage of a zebra mussel. So it's going to be tough to see on this small screen here. On the left is what a native freshwater mussel typically goes through in a life cycle. Males and females release their gametes. A lot of times in native mussels, the females will actually keep the fertilized eggs in their body cavity. Then most native mussels require a fish host, where that glochidia is going to attach to the fish's gills, be on there for some period of time, and then drop off and become an adult. Zebra mussels and quagga mussels don't require a fish host, which is another way they can outcompete our native mussels. Like I said, the gametes are expelled in the water, they're fertilized, and then they become free-floating veligers for a period of about 3 weeks before they settle to the substrate. So again, veligers, larval stage, does not require a host. They're free-swimming, meaning they're floating throughout the entire water column. They can survive up to 2 weeks without food. They don't really require any food intake during this stage. They'll remain like that for about 8 to 20 days, so 3 weeks is typically the maximum, and that depends on water temperature, and then they settle to the substrate. So in this picture here, on the left, the organism that has kind of the antenna coming out, that's actually just a copepod. What we're looking at is the circle in the middle of the picture there, and that's actually a zebra mussel veliger. How did zebra mussels get here? This is one that a lot of people are always going to ask you, well, how'd they get here? Zebra mussels and quagga mussels were introduced in the United States in the mid-1980s, and the general consensus is they came over in ballast water from ships from Eastern Europe. So when a boat leaves port, when they're loaded down, they'll take on water actually when they don't have weight on, they'll take on water to lower the boat in the water column so they won't tip in the ocean. So a boat coming over brought in water from the Caspian Sea or the Ural Sea in Eastern Europe, came to the U.S., and when it got to the Great Lakes and got shipping containers on it, it expelled that water so it wouldn't sink, and that's how those zebra and quagga mussels got to the U.S. And here's a map that's going to show how quickly things spread in the U.S. for zebra and quagga mussels. 1986, we only have 2 spots in the Great Lakes. 5 years later, pretty much covering the shorelines of the Great Lakes and starting to go down the Mississippi River. Another 5 years, we've pretty much covered the entire Mississippi River, Arkansas River, Ohio River, and then started moving up the Mississippi into Minnesota. Now we're 10 years later, you can see the Great Lakes has been completely overrun, and we're starting to see some coming up the Missouri River. Those 2 dots that are actually between North Dakota and South Dakota are no longer on this map. We found out that those were actually Asian clams, so they were taken off for this next map. Again, now in 2011 and 2011 was the first time they spread across the 100th meridian, or right in the middle of the country here. And those are mainly going to be quagga mussels that spread to the west. And then 2013 is the most up-to-date map on this web service. And you can see that we have now included Canada on the Red River to the north, and then still the entire Great Lakes area. So when we play it quick, you can see how quickly the progression really is. Again, John went over this, so I'll just touch briefly. Bureau of Reclamation performed their veliger samples. It was actually in August. We found that. I didn't change that on this slide. September 22nd, about noon, I was identified. They found 15 dry-scented veligers. They didn't know whether they were zebra or quagga mussels yet. And one of their samples from Angostura, they took 3. And the one that was actually positive was the one by the marina. They did that with cross-polarized light microscopy. And that's just a simple technique that's used to quickly identify veligers. Later in the week, they were able to confirm that they were quagga mussels through PCR analysis, where that's just kind of a technique where DNA is amplified and through markers they're able to tell if they're quagga mussels. And the same day, a different BOR lab did a complete DNA sequence and found that 75% of the DNA matched quagga mussels from the western U.S. So that suggests they were brought to South Dakota from a western population. And there's multiple lakes and reservoirs that it could have came from. Angostura, just brief stats. About 10 miles south of Hot Springs, 4,400 surface acres, pretty big shoreline, 42 miles of shoreline, 7 boat ramps, 3 outlet structures, and it's created by a dam on the Cheyenne River, which eventually flows into Lake Oahe. Which is why this map is a little bit startling, but again, this would be absolute worst case scenario here. So the dark red color would be waters that are directly downstream of Angustora Reservoir. You can see they flow up into Lake Oahe and then down through the Missouri River. The next shade lighter, the kind of the pinkish color, that would be a secondary or primary upstream spread. So that would mean the mussels would have to go back upstream, which would take significantly longer than going downstream. And the reason I'm terming them primary is because those are our major tributaries where there's a lot more water. And then finally, the lightest pink color is going to be the secondary upstream spread. So that would be small, maybe intermittent waters that might not be around every year. That would be where the spread is. With the only portion of the state that would be unaffected by this, just by spread from water, not including boats, would be that northeast part of the state that's part of the Bois de Sioux watershed. So future plans, we've already started working with federal and state agencies to address this. I've met with BOR a couple times. I've been on the phone constantly with them. We'll obviously have some education and outreach stuff going on. Potentially an eradication attempt if we get the population kind of more nailed down, kind of what we know in terms of the number of adults, if there are adults, and where those are at. It could dictate if we could do an eradication. Boat decontamination is an option some states go to. For sure what we're going to be doing, and we're doing it right now, is increased monitoring. Adult and veliger sampling is currently underway. Gene Gallinette's crew from Region 1 was out today to take veligers, and those will be shipped off to our Montana lab, which is what we use, and then half the samples actually going to BOR. So we're sending the same samples to 2 different laboratories so we can get a double analysis on them. And then more adult sampling will be going out tomorrow and doing some snorkeling, looking at boats, see if we can see anything attached. I mean, it could be pretty difficult. But we've also got the possibility of using a Fish and Wildlife Service dive team in the future, where they would come and they have certified divers that would be able to do some work for us for minimal cost. Then I'm going to go through this quickly. This is what a lot of people are going to be confused with in terms of our classification system. Start off with definitions here. A verification, that's when we have a scientifically based process to confirm the presence of an AIS. So that would be like the microscopy, the DNA, or the PCR. One of those would be a method to do a verification. A detection would be when we have something that we are able to verify, we have found a presence. But the minimum to verify a detection is 2 independent results from the same sample. So when we just had the one sample from BOR that said we had veligers, we weren't at a verification yet. We needed a second lab on the same sample to say, yes, these are zebra or quagga mussels. So we did meet the minimum for verification. And that brings us into actually classifying water bodies. So if we do not sample a water body, whether it's a small stock dam or something like that, we can't say that it's negative. We would say that's unknown. A water body that we do sample, but we have never made a detection, would be undetected or negative. Those are can be used interchangeably. An inconclusive water body is a water that has not met the minimum to verify detection. So when we first got the report that there were veligers, that's where Angostura was at. It was inconclusive. We didn't have enough information to say anything more. A suspect water body is one that has met the minimum to verify detection. So that's where we are now, because we have 2 or more positives on the exact same sample, and they were from independent labs. And now we're kind of in the waiting game. We just took our second set of samples to see what we've got. If one of those turns out to be a positive sample, Angostura would then be a water positive for quagga or zebra mussels. And then there's a little bit of a change where if it is positive and you are able to find adults, if you see multiple year classes and you can show that recruitment and reproduction is happening, then that would be termed an infested water. And these classifications are important because we also have a delisting criteria. So once a water body is listed as something, there's a certain set of criteria that has to be met for us to consider it negative again. So a water body that's inconclusive needs 1 year of negative sampling, at least 2 samples, one of which was in the same month as the first positive. Suspect is 3 years of negative sampling, so that's where we're at now with Angostura. Regardless of what happens with the second sample, it will be 3 years before Angostura could be considered negative again. If we do find more veligers or more adults, it'll be positive, which would then require 5 years of negative sampling. And then finally, if it's an infested population, we would have to do an eradication event, whether that be natural causes, the dam would have a rupture and the entire reservoir would drain, and then we would go sample for 5 years. That would be an eradication event. Or if we would do something like put chemicals in the water or some sort of treatment event, we could then term it negative from being infested. So it's really, it's a kind of a complex structure, and this is going to be really difficult to see. I tried to draw it out. Some people are visual learners, kind of to figure out how this works. It's just a progression of from the left side to the right side getting worse, from undetected to infested, and then what it would take to get back to being undetected. There's a lot of steps in this process just to make sure we know what our water bodies are classified. I can forward this on, or
would you hit on the temperature that veligers are able to produce and things like that, and how that affects some of our time frames right now?
Sure. We're kind of up against the wall because zebra mussel and quagga mussels typically will only reproduce or produce veligers when water is higher than 60 degrees. And we were out on Monday, Angostura was 62.5. So we're getting to the point where veliger sampling, while it's our best method and our quickest method to do it, may not be as effective because we're not going to be having the reproduction because our waters are too warm. So we're trying to get this on a really quick timeline, a lot of samples really quickly before that water gets too cold for them to reproduce.
What's the eradication method? And how successful is it? Do they know?
You know, some states have tried a couple different things. Nothing has really been tried with quagga mussels. It's always been zebra mussels. I believe it was Virginia tried a copper or potash treatment in a small quarry. I mean, it's a quarry, so there's no water flowing in or out, so they were fairly successful with that. A few years ago, Nebraska treated off at Air Force Base Lake, which is really controlled access, treated that with copper sulfate. They thought they had 2 years of negative testing, thought they had taken them all out, and then a few years ago they found out that zebra mussels are back, so that was unsuccessful. 2 years ago, Nebraska tried again with Zarinsky Lake, which is in the Omaha metro area, and they worked with the Corps of Engineers to drain the reservoir almost completely right before winter so that any zebra mussels on the shoreline or in the water would freeze and die. And then they brought it back up in the spring. I haven't heard if they are positive again or if they have seen anything. I would assume that's probably a fairly effective and probably cost-effective way to do it, but I don't know. I can't say if it was effective or not yet. It's still pretty soon in the process. There's also a chemical now called Zequinox that's just going through. It finally was approved by the EPA and the USDA to use, and they're still doing some trials to find out how effective it is. It's a chemical that just kills zebra mussels in any life stage, veligers or adults. But I would assume it would be fairly expensive for the size of the water we're talking about here with 4,400 surface acres.
So what are the problems? What problems do these mussels cause? Why are we all concerned? And I know we are all concerned, so why are we concerned?
Sure, we got a couple different effects that these are problems these mussels can cause. First being they're filter feeders. Each single mussel, I said they're an inch in size max, can filter over a liter of water a day. And we're talking about when there's an infestation, we're talking thousands of mussels per square meter. So there's, extrapolate that out, millions to billions of mussels in a system. So they can filter a lot of water quickly, which is the same effect our Asian carp have. When they filter that water, they're taking out the nutrients that our juvenile game fish, that our forage fish need to grow. So they're collapsing the food right from the bottom up. That's a biological effect. One that really applies to Angostura here is that Angostura is also an irrigation reservoir. They serve an irrigation district. So when if those mussels would reproduce and they would get into that irrigation canal, with those byssal threads, they can clog those pipes almost completely so no water is going through. So you're talking about potentially pumps would burn up. The costs to constantly repair those pipes and clean those pipes would be astronomical in terms of how many users that would affect. In the Great Lakes, they cause a lot of problems for hydropower facilities. They can clog up intakes. Just a multitude of problems with their ability to get into tight spaces and almost completely block pipes or any through-hull fittings in boats. They can get into boat motors and completely clog your boat intake and burn up your motor.
So can they leave Angostura by way of boats and just by water going down into the system? Is that how they can escape, if you will?
Yeah, veligers can survive for up to 30 days out of the water as long as they're in a damp environment. So a wet live well or something like that, they could survive in there potentially. And that depends a lot on the humidity and the temperature. We're getting to the time of year where there's not, it's not very hot, not very humid. They could live for quite a while out of a completely wet environment. Angostura has the 3 outtake structures. The first being there's the giant gate, the big gates they have to let water in and out. That typically is only used in emergency situations, I believe. They also have the canal structure, or it's the canal structure and there's 2 conduit structures. One's 4.5 feet in diameter, one's 6 feet in diameter, and those run depending on their irrigation demands, and to keep the reservoir level managed to where they need it to be. So I don't know. I'm not completely familiar with the Bureau of Reclamation's protocol for how they release water or when they release it, but it's on the Cheyenne River, and the Cheyenne River is always flowing, so there's typically some water that's going to be going through there.
So if we were going to work on preventing the escape, what would you do? You'd look at boats, you'd inspect boats as they leave, and then you'd be concerned or somehow try to address how the water's leaving the store? Is that what you do? Or?
There'd be a lot of discussions that would have to be done on that. The different states do different things. Colorado designates reservoirs as containment reservoirs and management reservoirs, where if a water body was positive for zebra mussels, it would be a containment reservoir where every boat that leaves is cleaned and decontaminated. There's a lot of different approaches to do that, and that's a discussion that we would have to have with our partners in this process as to what do we need to do, what's our next step.
With regard to partners, what other branches of government will be interested in this?
Like I said, this is the first release of this information, so I haven't been in contact with anyone other than BOR, BOR and the Fish and Wildlife Service right now. Potential partners would be Bureau of Reclamation, Fish and Wildlife Service, the Forest Service, because the BOR manages reservoirs throughout the Black Hills, and the Forest Service has an AIS person that would probably need to be involved. The Cheyenne River flows, at least in part, by two reservations, so there'd be two tribes that would be involved. State agencies, I would imagine the Department of Ag would be involved with it being an irrigation reservoir. They may have something to do with it. DENR, since it's surface water. There'll be a lot of different partners that would need to be included. And we're still so early in the process that we aren't quite sure what it's all going to entail yet.
So this winter, you need to come up with some kind of plan to deal with it. Is that what you're kind of thinking?
So I've asked John and his staff. Obviously, we're closely involved with developments and trying to do the right documentation, but I've asked them to pull a team together of all these interested folks, so that, yeah, I don't know that by November we'd have an action plan, but sometime after we get everybody together and talk about what the reality is on the ground or in the water, and what the potential action items might be, and some of those may require rule change, that we'd be back. We'll certainly come back to you with information, and where we would need action regarding abilities to be created through rule. We'd be working with you on that as well. So we'll mostly wanted to get this information in front of you today. Mostly it's information because it's still recent, and we don't know where it's going, and it may not. We don't know what's going to happen. It may not spread. I mean, we don't know this. And that's so we don't want to overreact. We certainly don't want to underreact.
And one thing also at this point in the season, with the water temperature dropping off, it's also the end of the irrigation season. The amount of boat use there's decreasing. It's a time when the releases out of the reservoir aren't going to be that high compared to some other times of the year, so it's a time where the potential for spread might not be as great, and we'll have some opportunity here to have a good plan we can put together and work with our partners. And if it is the case where it does spread and become something serious, we can address it as we go that way.
Other questions? Thank you, John. Nicely done. Appreciate it. We're going to button it up for today, but we're going into executive session tomorrow morning at 8 o'clock. Doug or Secretary Vonk, do you have any idea how long that one might be, so I can let the rest of the staff know?
I actually think this one might take a while. I would allow for an hour anyway.
Okay.
And if we get done a little earlier than that, then we could still just if you tell folks to be ready at 9, I think we can cover the rest of the agenda in short order.
Okay, we'll go into at 8, and I would guess probably about 8:45 or so. You all, rest of you, can kind of check in and see how we're doing. So we'll give it an hour at least at this point. So. Oh, go ahead, guys.